Okay, in this video, I'm going to walk you through how to use Cura to prepare the model that you that you started making in Potterdraw, and then you added the casting flange in Tinkercad. And now we need to use a software to slice the model. And so slicing software basically prepares the digital model for prepares it to be read by the 3D printer. So I'm here in Cura, and I have the appropriate printer selected. Now, Cura allows you to add several different printers. So like if you're in a school situation, you have access to several printers. You're going to want to make sure before you start doing all this that you have the proper printer selected. So I'm going to print this on our larger printer, and I make sure that I have the proper material. So I'm going to use PLA here. And so when I've already imported this, so I've gone to File and Open File, and this is the file that I created in the other demo. So everything looks good here. If I did want to change the scale, I could do that by saying like, okay, because I had changed that, I guess, a little bit earlier where I changed it to 110. But so let me just say that I'm going to print this at 100%. And these are the settings that I had put into the in Tinkercad. So so basically what I'm going to look at is all these options over here. A really important option is the layer height. And the layer height is going to dictate basically the quality of the print to some extent. So the finer the layer height, the smoother the print is. Although when you change this, has drastic effects on the time of printing. So you can see here it says 7 hours and 55 minutes. If I change this to 1.25 or 0.125, this is going to be a finer print and make it easier to pull out of the mold. But you will see the drastic difference in print time here. So it went from whatever that was, I don't remember, 7 hours or something, to 13 hours. But this is nonetheless, this is what I want to print at here. So you could print even finer at 0.1, or I'm gonna print this at 0.125. I'm gonna leave the wall thickness at 0.8. Sometimes you can get away with 0.6 on these, but you have to remember that the plaster heats up as it sets, and we're going to be pouring plaster over this. So that heat can make the surface of the object, or make the object itself actually kind of start to degrade a little bit. So a little bit of a thicker wall is going to be good for us. I'm going to take this infill density and take this down to 15. And that's going to take a little time off of this, but it's also just the 20% is a lot more than I need at this during this, in the walls here. It is going to print this, so the actual casting flange will have infill, and the walls will have a little bit of infill. So technically this could probably be 10%, but let's just leave it here at 15. I'm going to leave this printing temperature at 200 Celsius, and then I'm going to change this to the build plate temperature to 50, just because this particular printer seems to work best at 50. I have already loaded 1.75 millimeter filament into the printer, so I'm going to leave that there. I do want to enable retraction. So if you roll over, you can get a little preview of what each tool does here. So the retraction basically just pulls the filament back into the nozzle when it's moving here. So I'm going to leave the print speed at 60, leave all this stuff the same here. I do not need to generate support on this particular model because the bottom is so flat. Now, if I were printing this the other direction and I wanted to have support here, like if this were the bottom, then I would need to check that, and then I would need to check, one of these options here where if it's touching the build plate or everywhere. But in this particular model, I do not need that. The interior space here, as the walls come up, this is the printer will be able to span that without a problem. So, and then the build plate adhesion. Again, I don't need to have this selected here. So this is such a large flat space here where I don't need to have any sort of build plate adhesion. So I can select none here. And that might take out a little bit of time here too. So we're still going to be looking at probably a 12-hour print. Yeah, so that only took out 5 minutes. But and so, that's pretty much it. It's not uncommon for you to have quite a long print here. When I will go to print this, I will actually speed the printer up when it prints the casting flange, because I'm not too concerned with the quality here. It doesn't have to be super, super smooth. I'm going to put mold soap on it anyway. So, but then what I will do is make the printer go back into normal printing mode when it starts here at the bottom. So anyway, that's it. Basically what you're going to want to do is save the file, and it will save as a G-code file. Make sure that you have some sort of way of finding it easily. Make sure and save it to a place that you can find, and also make sure and save a relatively short file name, because when you put it on the SD card and put the SD card in the printer, it oftentimes doesn't show you the whole file name. It will show you the first 15 letters or something of the file name. So make sure you have some sort of descriptive information at the beginning of the file name so that you can find it on the 3D printer or after you load the SD card. But so that's it for this video. Just the main things are: make sure you have your layer height configured properly. Wall thickness, you want to be on a little bit more of the thicker side. And then these settings will probably be the same for most of the prints that you do. And if you have the flange on there, you don't need a build plate adhesion or support. So anyway, just experiment. Make sure that your object is sitting flat on the print bed. And that's it for this video.